when you're setting up this problem, okay, the first thing is notice the information. You have two sides and an angle. So let's see where this fits. Okay, I will always start with my angle here. Okay, so I'm going to call this B and label it 39. It just makes it easier for me to see, is there going to be, like, what is the pattern? So BC and CA, they don't share the point B, they share the point C. So I'm going to put my shared point right here. And then I'm going to look to see, this is the pattern of SSA. Okay, so I know that there's a possibility of two triangles or one. So when I look to see, my BC value is 14. And then depending on what my CA value is, I'm going to change the way I draw this triangle. So CA is a longer side. So I'm going to draw it where this is an exaggeratedly longer side. And the reason for that is it helps reinforce that I can't swing this A over and create a second triangle, right? If this is 21 and I swing it over, I can't have a triangle where this side is 21 and the side opposite, the obtuse angle, is less than that. So I know that there's only one possibility here. So this is the only triangle that I have. Okay, so I'm going to work from here. Okay, and when I do this, I need to find a couple different things. But the main thing when I'm looking for my area is 1/2 base times height. Just because of the way that I've oriented this, and not having to worry about whether this has to extend out to make a right angle, I'm going to use this as my base and this as my height. So I'm going to label that height. So I need to find what my base is. Okay, so here's my base value. Okay, so in order to do that, I do need to know the other pieces of this triangle. So here's my known ratio. So I can find angle A first from here. So I use my law of sines. Sine of A over the side opposite it, 14, is equal to my angles on top. So sine of 39 over the side opposite it, 21. So I'm going to multiply both sides by 14. And when I do this, I get my value 14, or sine of 39, I'll put a decimal in there, times 14 divided by 21. And so I get my ratio here, sine of A is equal to 0.420 approximately. So I can find my A value by taking the inverse sine of that ratio, which gives me my angle measure for A of 24.8 approximately. Okay, so here's 24.81 is my angle A. Okay. So when I work through this, in order for me to solve for my length B, okay, I do need to know what angle C is. So I'm going to find angle C by using triangle sum. 180 minus my given angle of 39 minus the angle I just calculated, and I get 116.2 approximately. Okay, so there's my angle C, and this allows me now to find my angle, or my side B, by using law of sines one more time, this time with my side B on top of the ratio. So B over the sine of the angle opposite it, the 116. Set that equal to the same known ratio, only this time the pieces get flipped. So the side on top over the sine of the angle opposite it. And so if I multiply both sides by the sine of that 116.19, I get B alone. And this is going to give me my approximate length for that 21 divided by sine of 39, all times the sine of this angle that I just calculated. And so I get 29.94 approximately for my side B. And that is my base. So I can plug that in here. Okay, and so the last thing I need to do is calculate what this corresponding height would be. And I can use either of these triangles once again, right? Because I have an angle here, I have an angle here. Since this is an integer value, I'm going to use this triangle to find h. With respect to this angle here, h is opposite. I have my hypotenuse, so which trig ratio is related? Sine. So the sine of 39 degrees is equal to opposite h over hypotenuse 14. Multiply both sides by 14. That gives me my h value. And so now I can do my calculation straight from here. 1/2 times my length, which I just found in the calculator. Okay, all times, and in here I have my height, which is 14 times sine of 39. So there's my full calculation. When I hit enter, I get my answer, 131.90. The units are not provided, so I'll call it square units. It is a two-dimensional area, and that would be the answer.